Okay, Mark, so here's a typical ignition system. I've drawn the battery with minus terminal and plus terminal. The minus terminal is grounded. It's usually just bonded to the frame of the engine block. From the plus terminal, we'll go to the back of the amp meter, and there's a lot of neat stuff inside the amp meter, but basically the amp meter will measure any load that goes through here. So I could take the amp meter out of this equation if you wanted to, but the amp meter will show discharge or charge of the battery. All right, so then next we would go to the key switch, so this would be closed when we turn the key on, and this would be open when we turn the key off. So when you turn the key on, that's going to pass power to the coil. And there's a plus and a minus side on the coil. So that power would go to the plus side of the coil. And then from the minus side of the coil, we go into the distributor. And inside the distributor, there's a set of points. And the points are merely a switch that's opened and closed by a six-sided cam. When the point comes to the follower on the points, it'll open up the points, and then when you go to the flat side, it'll close the points. Each time the points open, and this is a transformer. And transformers, you got a big can going to your house, and transformers work off of AC voltage. They won't work with DC voltage because you got to have the sine wave, and that magnetic field has to be being made and collapsed, and we don't have that up here. Well, not really. We don't. We're inducing then we're by opening and closing the points, we're making this work like an AC transformer. So you got 12 volts on one set of coils. And then you have a piece of iron down to the center of that coil, and then you have another set of coils. I'll draw it with another color, and you have this other set of coils that has proportionally more windings. And we take this 12 volts that we're putting in here on this side of the transformer, and then we'll end up with like 24,000 volts coming out the high tension lead in the center. And that 24,000, when these points open, don't ask me any more about how that works, just accept that that's what a coil does. When these points open, a spark is, and this magnetic field collapses, a spark is induced, and that, or a high voltage is induced. 24,000 is typical, and that 24,000 will travel out the high tension lead, which is the thick lead, from the coil to the distributor cap. All right, and that will then there's also a rotor in here. It will go out to the spark plugs. So that spark will. So let me show you this stuff in the real world here. So we got a little Model B engine over here, similar to yours. We've got to work our way around the ladder here. Okay, so here's what a coil looks like, ignition coil. So this is the ignition coil we've drawn over on the drawing over there. So it has a minus terminal and a plus terminal, just like in the drawing. And then here's the distributor cap. And so under the distributor cap is a rotor. And here's the points. So and here's the cam I was telling you about. So these points will open and close. They actually look kind of like the switch on the drawing. They'll open and close, and each time they open, they'll induce a spark that will, a high voltage that will come from here and go to the top of the distributor cap, top center. Okay, so when that spark happens, it'll come out. That high voltage will come out here, and it will go into the rotor, and then the rotor, by its position, will distribute. That's why it's called a distributor. It will distribute that spark to the proper cylinder at the proper time. So you've got no spark. So some of the possibilities are that your rotor button is damaged, and actually, for some reason, the first rotor we put in your boat did tear itself up. We looked for a root cause, which would be like inside the distributor cap. If one of these pins was out of place or twisted, it might have caught the rotor button. We couldn't find a root cause for it. So we determined that the root cause was just a faulty part. However, if you have a second one of these that's busted, then we have a different root cause, and that would have to be that we've got a problem with the distributor cap that we just can't see, but it's giving us a problem. So that's one thing you want to check. You want to pull your cap off to the distributor. All right, there's two clamps here. You may have screws instead of clamps, but there's the distributor cap will come off, and you want to check and make sure your rotor's okay. Other things that you want to check is you want to make sure your points, when this cam goes by, that your points actually open and close. If the points aren't opening and closing, then they have to open up for the spark to happen. They have to go completely closed for the magnetic field to be produced in here, and then they have to open for the spark to happen. So if you're not getting that cycle of open and closed, I had somebody tell me, I adjusted the points just like you said, and I looked at it and they weren't closing. So it wasn't just like I said then. But anyway, but the problem was that the points weren't going closed. He had them adjusted too far open, therefore no magnetic field, so the fact that it only sparks when they open. So if they opened one time, and that was it. So ways to test. Another possibility is that your coil has failed. So let's go back over the drawing real quick. Looking our way around 1935 Garfield wood, by the way. So some ways to test your coil and make sure your coil is operating if you were to ground ground your negative terminal, and then take this take this lead off the positive terminal, turn your switch on, make sure you have 12 volts, and just touch your terminal of the wire to this terminal on the coil. You would also want to have this loose, but have a good ground over here that you can jump the spark. I like to just go ahead and stick the spark plug in the end of the cord here and ground the spark plug, because then I have a gap that's about 30 thousandths, and the spark's got to be able to jump that gap. So the electricity does. So that's what creates the spark. So I like to test for a spark that way. And you touch that lead, and when you pull your lead off, you should have a spark. If you don't, then your coil's bad, or you don't have 12 volts here. But if you've got 12 volts here, you touch that and you don't get a spark, your coil is bad. So that's one possibility. The other possibility is that, of course, that your points are opening and closing. Yet another possibility is there's a little terminal on the side of the distributor where this wire hooks to. All right, so sometimes those terminals will short to ground. Therefore, you've got a circuit through the terminal to ground, and it doesn't care whether these points are opening and closing. So that's one other possibility that you have. Another possibility is there's a piece of copper on the points. There's a piece of copper that ends up being very close to and carries the current from the points. That ends up being very close to the distributor wall. Sometimes that'll short out to the wall. If this is a paper insulator, if it gets wet, it'll allow voltage to pass to the wall, to ground, and then and would reduce your spark. So there's some possibilities. Well, I'll show you those points again. I'll show you that copper band. So the other thing that you can do is, if you have an ohm meter, you can then put your ohm meter in between your points and your coil, and you should have let's see, now wait a minute now. Nope. Let's go from right here. We'll put an ohm meter in here. All right, with usually they're digital now, and so we're going to put our ohm meter, and we're going to ground the ohm meter, and so we should see an open circuit when this is when the points are open, and then we should see a closed circuit when the points are closed. Well, gee, how do I tell if I got a closed circuit or an open circuit? Usually, with the open circuit, you'll have a 1 in here. You'll have infinity, and then when you touch these two leads take your two leads and touch them together, you'll see this go to like 0 resistance, because you have no resistance. You have two leads touching one another. You have no resistance. So just try that out so you know what you're looking for. But you should have a wide open circuit when this is open, and no resistance when this is closed. And then, if that's the case, then your points are working right. If that's not the case, your problem's in here. So hopefully this will help get you started with your troubleshooting. I did promise you we'd go back and look for this copper strap inside the distributor. I'm getting ready to make it.
Oh, I gotta make it. I'm just asking if that's wrong.
Yeah, that's what we need. So here's the strap right here. Can you zoom in on that? There's a spring in here, and then there's a copper strap on the back side of the spring. You got to have the spring and the copper strap in place. Even this wire could that goes to the condenser could become chafed and ground out, so that would be another one. Of course, all that stuff's new in your distributor, so that shouldn't be an issue. This terminal can ground to this case, so it doesn't matter whether these are opening and closing. Those are the problems that you can encounter. So take a look and report back, and we'll zero in on what your issue might be and help you solve your spark issue long distance. Thank you, sir.